We're going to do section 7.1, which is solving linear system by graphing. You all have your graph paper to be able to take some good notes on. You need to know what a linear system is. It is two equations that have the same variables in them. Hint, hint, usually x and y. Thus the graphing part of it that can come into this. Because we know xy makes a coordinate pair. Usually there is one solution that is a coordinate pair, usually. As you saw on the joke sheet that you did for homework today, number 7 was what kind of lines? Do you remember? Parallel lines. And did they ever intersect? No. Therefore, what would the solution be for parallel lines? No solution. We're not going to be doing parallel lines today in our homework, but when we get to section 7.5, remember that information about parallel lines having no solution because they don't intersect. Little piece of extra information early for you. So I will say usually the two lines intersect. But we all know that parallel lines don't. So if you end up with parallel lines, you have no solution. But if they intersect, there is one solution, and you have to find that one XY pair where they actually cross each other. And that's what you were doing on the other 7 problems of your joke sheet for today, was finding that point where they intersected. So you've already been solving linear systems by graphing, and you didn't even know what you were doing. Except I said, graph the 2 lines and tell me where they intersect. That's the gist of what we're doing today. We're going to graph the 2 lines. We're going to find where they intersect, because that x and that y are solutions for both equations at the same time. And that's what we're looking for. The one xy pair that's a solution to both equations at the same time. Now, don't put, let's see, how do I want you to do this? On your graph paper, would you jot down the equations that are up here, and would you just very quickly jot in the graph that's already done for you? I'll pause for a moment for you to do that. What we are looking at here is a problem that's already kind of done for us. And what we have to do is tell what the answer is. So I'm just presenting you with a problem that is already graphed for you. The hard work is done. And now what you have to do is look with your eyes at where the 2 lines intersect and tell me what the XY pair is of where they intersect. That's what I want to know, the XY pair, where they intersect. In fact, I'm going to pause for a moment. I want you to talk to your partner and tell your partner where they intersect, and then we'll come back together. Okay, now that you've had time to talk to your partner, where do those 2 lines intersect? Jordan?
2, -1.
They intersect at 2, -1. And that's how you write your answer, is as an XY pair. We can see right here, this is where the 2 lines intersect. But we just don't say, yep, there it is, you know, arrow finger pointing. We write down the XY pair, the comma between them, parentheses around them, please. They are a coordinate pair. That is the solution to the system. Now, I'm just going to give you a hint here. We're going to solve today graphically. We're doing everything by graphing. But there are 2 other methods of solving linear systems. Both are algebraic, no graphing. And we'll do those in the next week as we're working through this. So you will have 3 different methods of solving a system, graphing and 2 algebraic methods. When I give you a quiz and a test on this material, I'm going to expect you to know how to graph these and give me an answer, and how to do them algebraically and give me an answer as well. I'm going to ask you for those certain methods. When you take a test in Spanish class, for example, how do you write all the answers? What language? In Spanish, you don't write them in German, do you? No. Do you write them in French? No. That would seem kind of silly, wouldn't it? If I ask you to graph a problem, to solve it graphically, would it make sense to do it algebraically if I just asked you to do it graphically? I want you to make sure that you are able to graph lines, because on my test, I'm going to specifically say, do this method to solve this problem, and I want to see if you can. Do this other method to solve the problem. I want to see if you can. It's just like going to Spanish class or German class or French class and taking a test. You have to write the answers in the language that you're taking the test on. Otherwise, I don't know if you know it. Yeah, I don't know if you know Spanish if you don't put them in Spanish. I don't know if you know how to graph if you don't do the graphing for me. Don't put this one on your graph paper. Just look up at it and decide what is the XY pair. Talk to your partner a second. That is the solution to this problem. Do I have volunteers to tell me what the XY pair is on this one? Okay, Jake.
3, 4.
Okay, it's 3, 4. All right. 3 over, 4 up. You always go left or right first, up or down second when you are naming an XY pair. Any questions then? Let's go on. I guess I have one more. Okay, let's see if you guys can talk to your partner on this one. Find the solution. Well, perfect timing, Isabel, wasn't it? All right. What do you have, Ben?
-1, -1.
-1, -1. All you had to do is look, where are the two lines intersecting? Can you guys graph a line? Yes? All right. Can you see where two lines intersect? Can you give the XY pair? That's what we're doing today. Okay, let's look at this one. Now I didn't graph it for you. Now you have to graph. All right. You have your graph paper in front of you. You have two equations. Are they in y equals mx plus b form? No. You can put them in y equals mx plus b, or if you want, you can graph them using x-intercept and y-intercept. That is a legitimate way to graph. So I'm going to pause for a little bit and let you graph part of it. All right, ladies, gentlemen, Jordan and Shelby graph their two lines for us. Jordan, would you tell me your y equals mx plus b for your equations?
Wait, which one did I? Okay.
I don't know, which one did you do, top or
I
bottom?
did the top one.
Okay,
Y equals -5 plus x.
-5 plus x. And Shelby, tell me your y equals mx plus b.
Y equals 3 minus 6.
All right. If you did not get your equations into these two y equals mx plus b's, you're not going to graph your line right. Okay? You need to be able to get them into slope-intercept form. And then once you have graphed the y-intercept, which is what Jordan put down here, you have to use your slope, which in this case is a 1. Remember, slope is rise over run. So you got to go up or down first and then left or right. Remember that back from chapter 4. If you don't know that, it's going to come back and haunt you like a really bad ghost. So make sure up one to the right one, up one to the right one. Don't want it haunting you in your dreams, dreaming about graphing lines and worrying about this. So make sure that you find out how to do that if you're having difficulty. Any questions here? What do we write as our answer then? We're not done. What's our answer? What do you say, Emily?
2 -3.
2 -3. How do I know that Emily's right and that Shelby and Jordan actually graphed it correctly? How do I know? What do you say, Jordan?
Would you plug it in with the equation?
Exactly. Check. 2 and -3. Let's make sure. 2 minus a -3. That's what we're putting in here. 2 minus a -3. That's really 2 plus 3, isn't it? 2 plus 3 is 5. Hey, that's what I'm supposed to have. How about this one? 3 times 2 plus a -3. So minus 3. 3 times 2 class is 6 minus 3. That's what we're supposed to get. You can check your answer on your homework today. When you're done, you'll know whether you have them right or not for your graphing. Because you're going to take the answer you got and put it back into both equations When you take my quiz, you'll know whether you have the right answers on the graphing. How totally awesome. You'll hand your quiz in, you'll know they're right. I don't even have to grade it. You'll have 100%. Gosh, I don't even need to give the quiz, do I? Just give you all 100%. Yeah, sorry. Sorry to dash your hopes. We'll give the quiz anyway. All right, let's solve this system by graphing. Okay, would you please graph here? What's the point? Where's the point of these two intersecting? Can you tell me what the point is, Jake?
Yeah, probably wrong, but 6.5 and 0.5.
So 0.5 being our x and
Yeah.
6.5 being our y?
Yeah.
Well, do you guys look at that and go, maybe? Let's check to see if Jake is right. Negative 0.5 and positive 6.5. Does that equal 6 when you add them together? Yeah, awesome. Okay, let's check the other one. 2 times 1/2, which is 1, right? 2 times 0.5 is 1, plus 6.5. So what's 1 plus 6.5?
Oh.
Not equal to 8. Oops, that one doesn't work. It has to work for both. So it was close, Jake, but unfortunately, I'm sorry, it's the wrong answer. Okay, looking at this one, it's like, Mrs. Deegan, how are we supposed to know, right? You think you got another one?
No solution.
Do those two lines intersect, Jake?
Yes.
Then there's a solution.
Okay.
Are those two lines parallel?
No.
Then I can't use no solution, okay?
Never mind.
All right, never mind on that one. Okay, there is a solution to this one, but it's hard to see, isn't it? I'm just trying to prove a point here. The point being, you can't always tell what the xy coordinate pair is when you're graphing, especially when they're fractions. Oh, by the way, the answer is this. Y'all would have come up with that, wouldn't you? Maybe not, maybe so. This particular problem would have been done much nicer through an algebraic way, but I'll teach you another day. Okay? So, may I just give you fair warning? Not always will graphing be perfect in the real world. On your homework today, though, they are really nice. Okay? So, if you're finding out that you've got something that looks like this in your homework today in the workbook, I would check out my graphing again because they're going to turn out to be nice integers. Okay? So, just a hint to the wise. You are all wise people. You can take that hint. Okay. Let us go on. How do I know if that ordered pair is a solution to this system or not? How do I know, Ellie?
You put the pair into the equation.
Exactly. Determine whether this pair is a solution to the system or not. Put them into both equations. It has to be true for both if it's going to be a solution to the system. Just like we were doing with Jake before. We had it worked for one, not the other one. I am so glad you gave me those answers. That helps out a lot with all of this. Thank you. Okay. I'm going to pause a moment. Okay, what have you decided? Does it work for the system or does it not?
Yeah.
It does. So we have negative 3 plus 1, yes, that's equal to negative 2. Negative 3 plus 5, yes, equals a positive 2. So what kind of an answer do I put down? Yes would be perfect. Solution would be perfect. Okay. Fabulous. Okay, so, yes, it is a solution. How about this one? Look at this one, work it out. Remember that we said if it was a solution to the system, it has to work for both equations. Are you finding it working for both equations? No? Then what do I put as an answer? Not the words no solution. Not a solution. All right. This ordered pair is not a solution. What other word, one word could I use? No would be appropriate. So if we see 2 times 5 minus 3 times 2 equals 4, what's 2 times 5? 10 minus 3 times 2? 6. Hey, it works for this first one. 4 equals 4, right? 2 times 5 plus 8 times 2 equals 11. 2 times 5 again? 10. 8 times 2 equals 11. 10 plus 16? 26. Equal 11? No, that is why that coordinate pair is not a solution. Please use the appropriate grammar there. That pair is not a solution. Is there maybe some other pair that is? Yes, there probably is some pair, but that one is not a solution. Any questions there so far? All right, let's move on. You're going to get some grids that you're going to have to do for me. We are not doing all of these, okay? You're going to do just a couple of them, and I think I'm going to choose this one and this one to do. So you and your partner are going to graph those two equations. They're all in y equals mx plus b, so you just have to graph and find out where their x, y pair coordinates are. So you can talk to your partner. I'm going to pause. Attention to the front here. We have both systems graphed. Any problems with the graphing of the two lines on either one of those? Any questions? Ben? How do you get number 20? She started out with a positive 2 for her slope, or excuse me, for her y-intercept. So that's a positive 2 right there. And then her slope is a negative 2. So she went up 2 and to the left. No, Mrs. Deegan. She went up. Okay, we can't go left and up 1. We have to go up or down first. Okay, let's take, so I should go up 2 and to the left 1, or I should go down 2 and to the right 1. Slope is rise over run. So we have to go up or down first, left or right second. Okay, so let's take this lovely line and say, oh, not that line, wrong line. Let's take this lovely line and say delete, right? And instead, we want to have our line going through this way. Okay, does that help you out, Ben? Yeah. All right. Up 2 to the left 1, up 2 to the left 1, or down 2 to the right 1. You with me on that, Angela? Okay, slope is rise over run. Did not end up in negative 2, 3 then, did it? Are we okay on the other line?
Yeah.
Yes? Okay. So, Ben, what do you say that the answer should be then?
Negative 1, 4. Negative 1, 4.
You say it should be negative 1, 4. Now the deal is, if we had tested Angela's points in both of the equations, we would have found out something's wrong. Because if we have 3 equals negative 2 plus 5, that one works, doesn't it? That one works great. Let's do the other one. 3 equals negative 2 times negative 2 plus 2. Negative 2 times negative 2, class, is 4. 4 plus 2 is? 3 equals 6. Uh-oh, something's wrong. So when you do your homework, test that XY pair back into your two equations to make sure that they are in the right spot. Thank you for asking about that line. As long as we're okay. Got a graph, okay. Anybody else? Getting the idea of what has to happen here? Fabulous. Just a reminder to you that when you're doing story problems, oftentimes you can use XY intercepts. Highly encouraged. Thus, I have a story problem. Okay, this is the last thing here today, ladies and gentlemen, our story problem. You bought 15 one-gallon bottles of apple juice and orange juice for a school dance. The apple juice was on sale for $1.50 per gallon bottle. The orange juice was $2 per gallon bottle. You spent $26. Write algebraic models for the situation, meaning write equations for the situation, and then we have to graph them so we can find out how many bottles of each juice we bought. I want you to talk to your partner a little bit and see if you can't come up with the 2 equations that we need for this. Start talking to your partner a little bit. All right, I'm liking the equations I'm seeing up there. We have x plus y equals 15, and we have 1.5x plus 2y equals 26. So 1.5 and x refers to apple juice, and x is apple juice over here, so that's a good thing. What would be the label on all the numbers that are in the second equation right now? What's the label on all the numbers that are in there?
Dollars.
Yeah, we have $26, $2, $1.50. So this is a total cost equation. What would we say that the top equation is a total of? Jordan?
How many you bought?
How many you bought? How many bottles, right? So a total number of bottles. So I had up here 15, there was a total, and 26 was a total. You got to have those 2 totals in your equations. Now we get to graph them. What's the x-intercept and the y-intercept of that first equation? The x-intercept and the y-intercept on that first equation. Kyle? 1? No. No. Remember when we find x-intercepts and y-intercepts, we put 0 in for one variable, solve for the other. 0 in for the other variable, solve for the first one. Remember that? Jack? Isn't it 15 each of them? Yes, remember you're putting 0 in for y, solving for x, and then we put 0 in for x, and we solve for y, and in this case, yes, they are both 15. So let's graph those 2 spots. 15, 15. It's in between 14 and 16, ladies and gentlemen. Now we're going to draw our line. How about the other one? Should we use x and y intercepts on that one? Or would you like to put it in slope intercept form? Ew. Let's use our x-intercepts and our y-intercepts. Put 0 in for y. Now you need your calculator, don't you? What's 26 divided by 1.5? 26 divided by 1.5. Who's got that for me? Rebecca?
17 and 1/3.
17 and a third. Heavens. 17 and a third. Okay, that's all right. We can deal with that. Now we're going to put 0 in for x. What does that mean? We're going to take 26 divided by 2, which is 13. Okay, that's much nicer. So I have 13, which comes between 12 and 14, and 17 and 1/3. Well, if this is 16 here, what's this number on the right-hand side? 18. So therefore, 17 is in between. We're just going to get as close as we can. 17 1/3, close as we can. Doesn't have to be totally perfect. Because of that 17 1/3, the author didn't give us a very big graph, did they? Okay, I drew my line. Where did the 2 lines intersect? Talk to your partner. Okay, ladies, gentlemen, as you're looking at this, okay, it looks like it's in this area somewhere, doesn't it, that it's intersecting? Ooh, that 17 1/3 that we had to graph over here. Is graphing perfect for everything? Absolutely not. Okay, what would make this graph better? If it was bigger, if it didn't go by 2s, if it went by 1s instead, wouldn't that be nice? Oh, gracious. Can you guys go by 13 on yours and 17? No, not very well. Okay. So, let's see here. Is it about 7? Whoops, not quite. That's not. How about 8? Is it intersecting at 8? 8 and 7. So 8 bottles of apple juice and 7 bottles of OJ. Does that work in the first equation? Yes or no? Yes. Okay, let's check the second equation. What's 1.5 times 8? 12. What's 2 times 7? What's 12 plus 14? Hey, it worked in both of them. Guess what our answer should be? Did I graph perfectly? No. That's why you have to be so careful in graphing, and it might work better, as Shelby said, make the graph bigger, right? That would sure help. Author, come on, help us out. Make the graph bigger for us. The questions on the graphing. You see, it can work great. We had some before when we had the girls up here graphing. We can work really well as long as you graph correctly. And then sometimes we see a little pitfall where it's like, oh, it didn't connect right on somewhere that I can tell what the point is. All right. Your homework's going to be nice, okay? Hint, hint. Your homework should be nice. Would you please take out